Hello everyone, welcome to Shabit Uganda e-learning. We're going to look at biogas and its importance and how it is manufactured. So on your slide, on the desktop, you can see we have gotten the biogas, which provides the thermal energy to serve for cooking requirements, and on your right you have got the biogas for mechanical energy for farm productive activities, like you are seeing a tractor this side, you are seeing a maize grinder this side. So the energy gotten from the wastes from the animals, from peelings from the kitchen, is further taken to the biogas digester, which you can see down here, biogas digester. And from the biogas digester we move to the biofertilizer. The biofertilizers we can get biofertilizers are the decomposing materials which have been left down in the biogas digester. So those ones are taken to the farm, whereby they act as biofertilizers to increase the crop yield. So the steam or the gas from the biogas digester, mainly methane gas, it can be methane gas, which is further taken to biogas for thermal energy. And mainly this steam is the one which we use mainly for in LPG stoves, cooking and sort. So we are seeing the cow, the pig. So these are cleaners, and modern farmers are deposited into the biogas digester, and from the biogas digester we collect the steam, which is methane gas, which is taken for biogas as thermal energy, whereas the decomposing materials, mainly the fecal matter, the cabbages, the remains, those kitchen wastes, are further removed from the biogas digester and taken to the garden to increase on the crop yield. Hope we are together. First of all, what is biogas? You can be asking yourself, what is biogas? Well, biogas, this is a waste product that is fermented to produce gas, which is mainly methane gas, and the methane gas produced is used as fuel for cooking, for running machines. And mainly biogas is gotten from animal droppings like the cow dung, kitchen droppings, and then the waste from the kitchen like the cabbages, lots of cabbages. Yeah, so let's dive through without wasting time. So we get biogas from leftovers, as well as discussed, and wastes from foods we eat. Animal waste can also be used to get the biogas, the cow dungs and the chicken droppings. So the waste and plant remains from which we get biogas include banana peelings, we get the potato peelings, the cow dung, chicken wastes and the pig wastes. So these are the raw materials for making biogas. We have gotten the dung, chicken wastes, pig wastes, potato peelings, banana peelings. Yeah. So looking at how is biogas made? Well, biogas is made from a special gas called methane gas. So this methane gas is the gas which is used in fuel. So when we use in Bunsen burners, when we use in cooking stoves. So the methane is produced in an airtight hole pit called a biogas digester, as earlier on you had seen in the previous slide. We had the biogas digester whereby the fecal matter is deposited inside, and later on the steam, the gas, after decomposition, the gas which is methane gas is taken off to the stoves and used as fuel, whereas the remains, the droppings, are tipped off and taken to the garden to improve on the crop yield. So the wastes in the digester ferment and decompose with the aid of bacteria. So what ferments this, what aids the decomposition of these wastes is the aid of some bacteria. And the bacteria do not use surface oxygen, and therefore use the type of respiration is called anaerobic respiration. So in order to produce biogas, you need to cover the raw materials, the cow dung, the potato peelings. You cover them so that you don't allow in oxygen to enter, because oxygen will kill the bacteria. The bacteria won't be able to ferment these wastes to produce the biogas which we need. So the type of respiration is anaerobic respiration for production of biogas. So the decomposition that occurs in the digester is also called anaerobic decomposition, because we don't need oxygen in the biogas digester in order to yield biogas, which we have used as fuel, as fuel for cooking. Yeah. So now the biogas is collected in a biogas tube where it is taken out for use. So that in that tube we tend to find that we shall have methane gas, which is taken to be connected to the cookers. I think that all of us have been at a hand looking at a gas cylinder that goes in the tube which connects to the LPG stove, the cooker, and then supplies the cooker with gas. That gas one that you ignite with a matchstick, producing a flame, a blue flame, which is a luminous flame. And yeah, that's the point about the biogas. Okay, it's collected through a tube, taken out for use. Now we have the inlet valve is used for powering in new plant and animal matter. So the inlet was there whereby the cows in the previous slide, the cows droppings were being fed into the digester. So it's called the inlet, which is used for powering in animal matter. So the liquid residue that remains after collection of biogas is called effluent, while the solid is one is called the slurry or the sludge. So it's the sludge that we take into the gardens to improve our crop yields. We're going to look at the structure of a biogas digester. I think this child is defecating feces, and these feces will move directly to the biogas digester, which is cooked up to prevent what? To prevent entry of surface oxygen, which will disrupt our fermentation process. Now, energy resources from animals. Animals get energy by feeding on plants, and the energy from animals can become available to people in the following ways. Well, once we people eat animal as food to release energy stored in the muscles, animals are used to perform tasks like transport and pulling of roads. Animal wastes can be used to produce biogas, like the cow dung. Yeah. Now we look at the energy sources from wind. We look at air or oxygen is used in respiration to support living and burning. Carbon dioxide is used to put off fire. In most cases, you tend to find that once buildings have lit up, we don't pour their water because that water contains oxygen, dissolved oxygen. So we need carbon dioxide since it has no property of supporting burning, so it puts off fire immediately. Compared to oxygen, oxygen supports burning, so it will further continue. The building will further continue to light up. So the energy from wind is also a raw material for photosynthesis. The energy of air is used to drive out vapor from clothes to make them dry. Wind enables boats and those to sail on water. Those are like the old boats we used to use, which used to have clothes, and those cloth like structures would be blown by wind and hence sailing on water. Wind is used to run windmills. Wind is used to power water pumps. We shall look at the importance of energy sources. So you have got the radiant heat from the sun that keeps the earth warm. Use of renewable energy resources like wind, which conserves the environment. People earn income by setting up biogas technologies. So these are the different energy resources whereby you've got the renewable energy and then the non-renewable energy So look at the plants are a source of food to people. They increase production rate when machines are used. Electricity produces heat and light, which is used for domestic use. Raised bean biogas digesters are used as fertilizers, which improves on the crop yield. Windmills can be used to pump water. Thank you very much for watching. Love you too much.